I welcome all of you again to this second part of electrochemistry. We are considering ICSE syllabus, class 10. Now, here we are studying acids, bases, and salts as electrolytes. Now, when acids and alkalis, sometimes salts also, are dissolved in water and they dissociate to produce ions, and this dissociation occurs in molten state or in aqueous solution. It provides free ions. Now they can be classified as strong or weak electrolytes depending on their degree of dissociation, and this degree of dissociation is defined as this one. In easier words, we can say that number of molecules undergoing dissociation per 100 molecules. This is the term for degree of dissociations. Here the book says that all salts are strong electrolytes. I do not agree with this one. We can say that most of the salts are strong electrolytes. Some salts are weak electrolytes, for example barium sulfate, silver chloride. These are weak electrolytes. They do not dissociate much in water. Okay. Now let's proceed to this chart. This chart exemplifies strong electrolytes of acids, strong electrolytes of bases, and strong electrolytes of salt here. It also categorizes weak electrolytes of acids, weak electrolytes of bases, and weak electrolytes of salts. I hope you will not have any problem in studying these three categories. Try to memorize them. Now we are going to study two things. The first one is electrolytic cell and the second one is electrochemical cell. In electrolytic cell, we pass electricity to carry out a chemical change, and in electrochemical cell, a chemical change occurs to convert chemical energy to electrical energy. For example, simple voltaic cell, Daniell cell, etc. In electrolytic cell, also called voltmeter, it is a non-conducting container having two electrodes, cathode and anode, and it is connected via an external DC source. This is all about all these things. Now the electrodes, two metal plates or wires or graphite rods or gas carbon rods immersed in the electrolyte through the current and current enters to the electrolytic mixture through these things. These are called electrodes. Now the anode and the cathode, we must pay proper attention to this one. Anode is connected to the positive terminal of the battery and cathode is connected to the negative terminal of the battery, and therefore anode, as it is connected to the positive terminal, it is termed as the positive electrode, and cathode, as it is connected with the negative terminal of the battery, so it is called negative electrodes. Ions that go towards the cathode are the cations, and hydrogen and other metals are in this category. So hydrogen and other metals are deposited in cathode, and as cathode is a positive electrode, for this reason they are called electropositive elements. Whereas anions, mainly of nonmetals, they go to the anode and get deposited there, and for that reason they are called electronegative elements. This we'll study a little later as we are discussing this anode and cathode, so I discussed it here. Okay, when the electricity is turned on, the respective electrodes acquire their charge anode becomes the positive one and cathode becomes the negative one. So as anode is positive, so anions will go to anode and cations will go to cathode. This is most important, and I remember all my theory by just these two lines. Remembering these two lines where A to A and C to C, I remember anion to anode and cation to cathode. Now, what is the difference between anode and cathode? As we have learned a little, anode is connected to the positive terminal and cathode is connected to the negative terminal. As anode is connected to the positive terminal, so anions will migrate to anode, and cathode being connected to the negative terminal, cations will migrate to cathode. Anions on migrating to anode will lose their electron and get oxidized, whereas cations will go to cathode, accept some electrons, and they will get reduced. So oxidation occurs at anode and reduction occurs at cathode. This is all that we need to learn. Ions. Atoms or group of atoms which carry a positive or negative charge are called ions, and cations that carry positive charge, and anions are those ions that carry negative charge. Okay. The one more thing that we need to remember here is that the charge on the ion, may be positive or negative, is the amount of charge that is monopositive, bipositive, tripositive, or mononegative, binegative, dinegative. It is equal to their valency. So this gives us a good idea to understand about valency. If we see sodium has monopositive, calcium is dipositive, and aluminum is tripositive, so their valency is 1, 2, and 3 respectively. Likewise, phosphate has valency 3, chlorine has valency 1, and here sulfate has valency 2, hydroxyl ion has valency 1. So this is all. Now this difference between the ions should not be a problem to all of you, so I leave this part. Here we are going to study oxidation and reduction from electronic point of view and from traditional point of view. From electronic point of view, we can say that oxidation is a process in which electron is removed from a substance. That substance can be a neutral one, a cation one, or an anion one. Oxidation can also be defined as a chemical process in which addition of oxygen or removal of hydrogen occurs. I generally exemplify the case of magnesium to my students. Now, from the traditional concept, as oxygen is added to magnesium, so magnesium is oxidized. This can be explained by electronic concept also. The compound magnesium oxide contains magnesium plus plus. Let me clear the board. Contains magnesium plus plus and oxygen is present as oxygen minus minus, that is oxide ion. So when magnesium reacts with oxygen, magnesium gives up 2 electrons to form magnesium plus plus, and magnesium is oxidized. For this reason we say that when oxygen adds to someone, of course in an electrovalent way, then that substance is oxidized. Okay, this should be clear to you now. Now removal of hydrogen. Hydrogen is very weakly ionic, but still if we consider its ionic nature, then H2S should be H plus 2H plus ions and S minus minus ion. When it comes in contact with chlorine, this sulfur is separated, so S minus minus turns to S. That means it is giving off 2 electrons, so it is oxidation. That's how we explain it from electronic point of view. Now agents, chemicals that oxidize other elements are known as oxidizing elements. They help others to remove their electron, leave their electron. For example, chlorine here, in this case oxygen here in these two cases. Okay, we have examples and I think you will not have any problem regarding these examples. Okay, read it. Then we have reduction. Reduction is the reverse process of oxidation. In oxidation, electron was lost, and in reduction, electron gain occurs. So electron gain can occur to a cation or a neutral atom. Even an anion can gain electron. So in all these cases, they are all going to get reduced. So reduction is a chemical we can again say that in traditional way that reduction is also defined as a chemical process in which oxygen is removed or hydrogen is added. Now this thing can be understood from these examples. Here you see the example of cupric oxide rather. In cupric oxide, copper is present as copper plus plus and oxygen is present as oxygen minus minus. This copper plus plus must have taken 2 electrons to convert to copper metal. So as it is receiving the electrons, it is getting reduced. So this is the electronic concept, and from traditional concept, as it is reacting with hydrogen or carbon, hydrogen for copper and carbon for zinc, they are getting reduced. Okay, addition of hydrogen also leads to reduction, and this can also be termed explained from electronic concept of view. Here you see elemental chlorine has converted to electronegative chlorine here. So chlorine is partially negative if it is gas, and chlorine is fully negative if it is in aqueous condition. So if chlorine is fully negative, that means this chlorine atom has taken up 1 electron to convert to Cl- ion in hydrochloric acid. So this is a reduction process. Examples of reducing agents: we have solids, liquids and gases, as we saw for oxidizing agents previously. Okay, now we have theory of electrolytic dissociation. The credit goes to Arrhenius. In 1887 he gave us a concept. Now an electrolyte on dissolving in water dissociate to provide free ions, and these free ions flow to carry electricity. These free ions can be positive ions or negative ions. Positive ions go to cathode and negative ions go to anode, and thereby they help in conducting electricity. Now all ions carry electric charge, and therefore all are responsible for the current that is flowing in the solution. The more the ions, the more is the current that is flowing through the solution. That is, the conductivity of the electrolyte will depend upon the concentration of the ions in the solution. Okay, the solution is electrically neutral as the number of cations is equal to number of anions, and an equilibrium is established between the unionized molecules and the ions produced. This is always there, as ions are continuously being removed and being created, so an equilibrium is maintained there. Non-electrolytes will never conduct electricity as only molecules are present there. Okay, now degree of dissociation, we know, we studied it earlier, that it is the extent of dissociation undergone by a molecule, and it is defined as a number of molecules undergoing dissociation per 100 molecules. Okay, the difference between Arrhenius concept and modern concept: Arrhenius considered that only water forms ion, that is, water forces the electrolytic compounds to ionize. But the modern concept says that ions are already present in those electrolytes, but as they are in solid state, strong electrostatic forces restrain the ions to move from each other. This is how it happens. And water renders the ion mobile. Water helps the ion to get separated from each other, and thereby water helps in providing ions. That is by breaking the electrostatic force. Okay. Now conduction in compounds. The electrovalent compounds consist of aggregate of positively charged ions held in their position and negative charged ions held in their position by strong electrostatic forces. Hence, in solid state, they will not be able to conduct electricity, but when they are dissolved in water or when they are melted, the barrier of electrostatic force will break and the ions will become mobile, so it will be able to conduct electricity. Some covalent molecules, very good example, this trio you should remember: hydrogen chloride gas, ammonia gas, and water. These are covalent compounds which are polar in nature and they ionize in aqueous solutions and conduct electricity. For water, we need to add some acid, a little bit of acid, a little bit of base or salt to make it ionize. Now, characteristics of electrolysis, that is what actually happens in electrolysis. The passage of electricity through an electrolyte causes the positive ions, that is cations, to migrate towards the cathode, and negative ions, that is anions, to migrate towards the anode. And the number of electrons gained by anode is equal to the number of electrons given by the cathode. The electron exchange occurs at the electrodes, on the surfaces of the electrode. So we can say that the surface of the electrode is the place of reaction, and here the elements or molecules are either deposited or liberated. Okay, now this thing I taught you a little earlier, that only hydrogen and other metals are liberated in cathode, and hence they are called electropositive elements. And the similar is for electronegative elements, as they are liberated in anode. Okay, the mass of a substance produced in the electrode is directly proportional to the amount of electricity passed through the electrolytic cell, and this is Faraday's law. Faraday has given another law also, that it will depend on the nature of ions present in it. We will study it in higher classes. Okay, now this seventh point, it is important that the process of electrolysis is a redox reaction. Suppose we are electrolyting a molten solution of sodium chloride and not an aqueous solution. In a molten solution of sodium chloride, we will have sodium ion and chloride ion. Sodium cation will go to cathode, and there it will undergo reduction to produce sodium, and anion chlorine will go to anode, and here it will produce chlorine atom, which ultimately will combine to produce chlorine gas. Therefore, the overall reaction is this, and this is the reduction reaction, and this is the oxidation reaction. So we can say that electrolysis is a redox process. Alternating current generally do not have any effect on electrolysis, as the direction of current changes very frequently. And one very small point may given under aesthetics is that electricity is counted by the unit Faraday, and that is equal to 96,500 coulombs approximately. Okay, now we will study electrolytic dissociation. The process by which ionic compounds dissociate into ions in or in fused state is called electrolytic dissociation. So ions are already present in the crystals here, and when we melt it, this electrostatic attractive force breaks and the ions become free to move. In fused state this happens, and in aqueous state what happens? In aqueous state, water molecule will help them to get separated. Water molecule is polar in nature. Here is the water molecule that we can draw here. It has this angle is 104 degree almost, and this is delta negative, and this hydrogen is delta positive. This hydrogen is also delta positive. So water has negative end and positive ends also. So this negative ends will pull the positive part of the salt, and the positive end will pull the negative part of the salt, and thereby they will dissociate. Now as we understand dissociation, we are going to understand ionization. Ionization occurs for covalent molecules that are polar in nature. We indicated of the trio, water, ammonia, and hydrogen chloride gas. Here the book takes hydrogen chloride gas as an example and explains it. Hydrogen chloride gas is unionized in a liquid state, but as it is polar, when I put it under water, this hydrogen chloride ion separates. This chlorine will get separated with the H plus end of water, and this H plus will combine with another water to form hydronium ion, and thereby ionization will occur. That is, ions were not there previously, and after mixing it with water, ionization occurs. Here the difference between ionization and dissociation has been given. Ionization occurs for formation of positive or negative charged ions form molecules which are not initially in the ionic state, but dissociation is for compounds which are already in ionic state. And then the next one is that polar covalent molecules will show ionization, for example water, and electrovalent compounds will show ionization, so dissociation, for example potassium chloride. Thank you very much for being with me. All the best, my dear students.